Let's see. The lacrosse team is hosting a dance as a fundraiser. They sold 87 tickets and earned a total of $730. Now, each individual ticket is $3 and each couple ticket is $5. We need to write a system of equations that represents that same scenario. So, throwing it back to, I think, 2 tests ago, systems of equations, it's because they don't go away. They keep popping up in your STAR tests and your SIM tests and your final or whatever. So we have to keep on doing them, I guess. All right, so we sold a total of 87 tickets. All right, we've got individual tickets and we've got couples tickets. So let's just say I will be individual tickets. I'm just going to say ticks. And C can be couples tickets. All right, so if I add those two up, I plus C, I need to get 87 tickets. Total of 87 tickets. So I plus C equals 87 total tickets. Now we're going to talk about the money. I know that the individual tickets cost $3. So I'm going to say 3I plus $5 per couple ticket, 5C equals, per total amount, $730. $730. All right. And it just says, write a system of equations that would represent that scenario. If we wanted to, we could pull up our handy-dandy Wolfram Alpha. I plus C equals 87, comma, 3I plus 5C equals 730. This is if it asked you for the answer. Did I plug that in wrong? I plus C equals 87. 3I plus, oh, you know why? Let's just call this D or something. It thinks it's imaginary numbers. All right, so these would be our answers. Kind of weird. 469 divided by 2. They would meet somewhere here on the graph. Oops. Looks like 234.5, negative 147.5. I'm assuming that's why they asked you just to write the solutions, because it would be a weird number. All right. So just make sure you remember how to set those up. So we've got a total of 87 tickets. So the individuals plus the couples have to add up to 87. The cost, $3 per individual, $5 for the couples, has to total $730. There's your two equations. All right, number 8. So this one is exponential. Haley bought a pair of Jordans for $130. Every year she doesn't wear them. Oh. Every year she doesn't wear them, the value of the shoes will triple. All right, so right off the bat, I know that this one is exponential because it starts at 130 and the value triples. All right, so it starts at 130 and the value triples. All right, write a function that can be used to represent the value of the shoe after Y years. So I know it's exponential because they're tripling each time. It's not linear. All right, so we've got Y equals A times B to the X. A is going to be my starting amount, my initial amount. This is my initial amount. AKA my y-intercept, by the way. And then B is going to be my growth rate in this problem. It's growing by triple each time. So that is my growth rate. X would be time, or Y in this case, I guess is what they're saying. Let's change that to an X. So we already have a Y. All right. Okay, so let's write our equation. Y equals, the value starts off at 130. 130. It triples each year, so 3 to the x. All right, that's our function. If it asked us, how much would they be worth in 5 years or something, we would plug in that 5 right here where the x is. That would be worth a lot of money if they're tripling each year. All right, that's number 8. Number 9, put true and false next to each statement about the graph of y equals 8 times 2 to the x. So at this point, we would pull out our handy-dandy Desmos graphing calculator. Pull it out. And it is y equals 8 times 2 to the x. All right, so let's see what our options are. I'm just going to look at my paper copy over here. The graph has an x-intercept at 8, 0. That is false. 8, 0 is over here. There's no function over there, so I'm going to put false for that one. All right, the graph has an asymptote at y equals -1. Well, I don't think so because it's going all the way down to 0. It's getting infinitely closer and closer and closer to 0. Our asymptote is y equals 0, not y equals -1. So that is false. Or y equals 0, yeah. All right, the graph has a y-intercept at 0, 8. 0, 8. That is true. The graph decreases from left to right. Well, check it out. Left to right, it's going up. So that's false. And the graph has an asymptote at y equals 0. Yes, that's true because it's getting closer and closer and closer to 0. Never actually touches it, though. So we say true. The graph's range is from y is greater than 0. So everything greater than 0 is the range. That's true. Because remember, range is up to down. So everything from 0, greater than 0, all the way up, that's going to be our range. So that's true. Hi, can y'all lower your volume again? Okay, thanks. All right, so there's all the true falses that we discussed. So we did not have an x-intercept at 8, 0. That was false. The graph did not have an asymptote at y equals -1. It was at y equals 0. It did have a y-intercept at 0, 8. The graph did not decrease, so that was false. Had an asymptote at y equals 0. That's true. The range is from 0 all the way up to infinity, so that's true. And number 10. So this is one of those exponential growth functions. So he starts off, he has to pay $3,000 for property taxes, which sucks. I've done that before. Each year they increase by 3.8%. How much will they pay in taxes in 9 years? So anytime you see a percentage, that should be a dead giveaway. You need to convert that to a decimal. All right, so let's do that first. But let's keep in mind y equals a, 1 plus r to the t is the formula that we're going to use. All right, so step 1, let's convert this percentage to a decimal. Right, and once we do that, that means I have to shift my decimal to the left 2 times. To the left, that's going to be 0.038. Right, 0.038. Remember, you're moving that decimal to the left 2 times. So now I've got my R. Step 2. Find your initial amount. That's going to be your A in the formula. Well, there it is. $3,000. So A equals 3,000. All right, and then step 3, find the amount of time. Find T. It tells us in the problem. It's 9 years. 9 years. So I have everything I need to plug into the formula. Y equals 3,000. 1 plus 0.038 to the 9th. All right, that's 3,000. 1.038 to the 9th. This is a calculator problem, so let me pull out the calculator. Like I said, you can use whichever calculator you want. When I'm calculating, I use Wolfram. When I am graphing, I use Desmos, so totally up to you. All right, so 3,000 times 1.038 to the 9th power. You can also do the extended keyboard. And I think raise the power, maybe not, to the 9th. All right, it is a repeating decimal, but this is money that we are talking about, so I'm going to round. It's going to be 41.96 and 60 cents. 41.96.60. Let me write that down. 41.96.60, because this is money we're talking about. All right, so how much money is he going to pay after 9 years? He will pay this is running out of ink. He will pay $41.96.60. After 9 years. All right, let me stop the recording.